Hello, everyone. How is everyone doing? Can you guys hear me? Perfect. And perfect. How I hope that everyone had a fantastic spring break. I hope that you guys are ready with energy. And we're gonna be talking about 3D printing, which is completely connected to project-based learning. And so that's why we are having Hector again, and he's our 3D printing specialist. He has been working with 3D printers for, I want to say, about 7 years, 8 years, Conejo, Hector?
Yeah, roughly. Yeah, that sounds about right. 7 years, hopefully. It's been a
from
long
uh, from the very old Ultimaker 2s that I was able to see when they were about to die, and then we moved to Ultimaker 3s and so on. So we're very happy to have you, Hector. I'm gonna leave you to present.
Alrighty then. Thank you so much, Fernando. Hello, everyone. I hope you're doing well. I hope everyone was having a wonderful spring break and that you're doing well and your loved ones as well. So I made a promise to everyone that this time, the presentation would not last for 1 hour and 30 minutes. So I'm just going to put a timer right over here that this time the presentation will only last for 30 minutes. So hopefully we can do it. So welcome to this session. As you can see, we're going to cover 3D design and print. The whole scope of this presentation is to go over small. That means we have some new members right here. There are actually students that work within our department and also with other departments such as Create and STEMGrow and Yes You Can. So that's going to be introductions, and then we're going to talk a little bit about 3D design and print. That means some machines, some equipment, and then some types of softwares. Then we're going to go with some websites where you can actually get to download some STLs, and then and at the end, a way to where you can actually get to 3D print. That means cloud-based, so that so you can actually you can send things to be printed from your house. Then we're going to do a small demo on Tinkercad, and then you're going to have 1 hour where you can actually get to use the software that I'm going to be teaching as a small intro, and then people are going to be able to assist you and help you out. So this is more hands-on activity. So as a small thing is we're going to do 10 minutes, so that way everyone feels comfortable with catching up, or if you're barely getting right over here online, you can actually get to introduce or talk. Maybe you're in a different table. So that's up to you if you want to use any of these topics to ice break. That means how was your spring break, or what other things you have done. I don't know why it's not showing up, but you can definitely have 5 minutes to have a conversation. Then what I'm going to do is the next 5 minutes, what we're going to do is you're going to change with other tables. That way you can get to know other people. So 5 minutes just talking with people in your table, and then another 5 minutes to change. So let me pause this. Then we're going to go into your own tables. I hope all of you had some time to talk about some good conversations, share some of your experiences that you had last week, and I hope you have a lovely time on those 10 minutes. So as promised, we're going to continue with our time. So on this slide, as you can see, there are some professional students with us. You're going to be able to recognize them, or you already have some conversations with them. So as you can see on the left side, that's going to be Monica Laviaga. She's actually a senior student in mechanical engineering. So she will definitely help you out. Or if you have any questions in terms of CADing, that would be the best person to ask. Then you can definitely ask more questions for her, as she is actually going to start working with Cummins. So the next person is going to be uh, Connie Consuelo Ramirez. She is from computer science. So she has been working with us for 2 years, if I'm not mistaken. She was part of Techie in the summer Techie camp. Um, so that's pretty much about it. And then the next people that I want to show is going to be Memo, who's also going to be assisting us for today. He's also mechanical engineering as well. He's into aquaponics. So if you have any questions in terms of aquaponics, you can definitely ask him. That's one of his passions right now. And also setting up a 3D printing recycling system. Then the next one will be Fernando Monroy. I'm pretty sure you already know him by now. And then last but not least, that's going to be Carla Ayala, who also you should be familiar with her right now, as she is also, along with Fernando, coordinating to teach. So as introductions, we're going to go to the next slide, which is Intro to 3D Design and Print. So these are small videos I just want to show where the applications can be anywhere. As you can see on the left side, there are already 3D printing a car for the most part, the chassis, and then add some extra components. And the one on the right side, the materials that they're actually 3D printing, you can hopefully continue to expand on, be able to change its adaptability, which means if you notice on this video, it could also increase or decrease the temperature. So apologies about that. I don't know why my presentation crashed. So let me just, hopefully I can open it. Apologies, some technical difficulties. I think it's due to all of my videos that I actually could. So yeah. My computer is slowly dying. Hopefully it could process again. Yeah, my Google Tabs, you don't want to look at it. You'll be surprised, or you might have a heart attack about my Google Tabs. So real quick, right away. So as I was mentioning, you can adjust the print by increasing or decreasing the temperature on the right video. So that's opening a lot of fields or applications that we're going to see later on as we continue with this new technology. Another set of examples, as you can see, also with be able to manipulate or change the material itself. Think of it like parachutes, or maybe just applying some electricity, some current. You can probably be able to change or adapt the material itself. So that's the one on the top left. Then there's another thing that even it's not only just engineering, but also if you're interested as in terms of arts or business, this is something that they call tessellate. So instead of having a solid fabric, you'll be able to apply some kinematics that's more on the engineering field. So that way you can actually simulate or be able to reduce the whole cloth fabric and then be able to manipulate or make these kinds of structures where you can definitely morph them or compress them, tessellate. So I'll just write it right over here so that way you can be familiar with it. So apologies, but my computer, it's way super slow. So hopefully it doesn't crash again. So that's due to all the videos and PowerPoints that I'm sharing right now with you. Another field of applications that you can see, or a lot of people are applying, and the holy grail is on the medicine world, on the medical field. That means for nursing or surgeon practitioners, in case they can actually be able to 3D print models of organs, or be able to do some trainings, or be able to practice like real situations or scenarios for surgeries or for wound treatments or for any kinds of emergencies. So that's the one on the left side. And then another set of example is 3D printing organs. They have been able to successfully 3D print cartilage, so that means they can actually 3D print ears and nose for sure. And then they have been able to successfully print partially a kidney. So that's one of the features that hopefully maybe in the future we might be able to 3D print organs. So that's where there's a lot of interest right now. And I can definitely talk about other ones, like for example, constructions. Um, they are building 3D machines where they can actually build a house in one day, or um, there are arts where, for example, on this side, you can actually 3D print a saxophone, or you can actually create an instrument that it can be played as a violin or as a cello. Uh, I do believe that this instrument, it can play on 7 different types of instruments in just one simple design, or you can go into any kinds of business, like even uh, food printing and also metal printing. So as in terms of different types of processing for printers, there is the most classic ones, or the one that it's very accessible for everyone, which is fused deposition modeling, FDM. So basically how it works, the 3D printer, is that you have the material, which is polymers, plastic for the most part. Then you have your heated extrusion right over here, which is at roughly 200 Celsius degrees. Then it just melts the plastic layer by layer, as you can see. That's how you'll be able to have a 3D print object. So this is just an example about it. Sorry about the audio, just to wake you up. Sorry about that. And then we also have these kinds of printers available at the makerspace, which is stereolithography, SLA. So basically you have a laser, and then it actually just bounces, and then it would actually be able to do layer by layer. It solidifies it from liquid resin to solid resin. So it's this one right over here. So it's a small clip of some of the things that we have been able to do, which is a beta pick. And you can see the pros and cons about this software, this printer, is that it takes a long time because it tends to go up and down layer by layer. So that's why there are some pros and cons for using different kinds of 3D printers. So you have better quality. Some of the other ones you may have a rapid prototyping. So other ones are for different kinds of materials. So it all comes to what your application is at the end of what you're trying to accomplish. So these ones are more tech. That means these ones will range. The previous ones, you can actually get them affordable. That means ranges from FDM, probably $50 there are, but I cannot guarantee they're going to be the best ones, or you might get the best quality. But you can go FDMs from $50 all the way to probably $10,000. So it all depends on your experience and build volume and some many other technical terms. Then the previous one, stereolithography or SLA, those ones vary ranges from 3,000 all the way to probably more than 30,000. So it all depends on your applications. Then this one, think of it like SLA, but the difference is that this one, instead of doing layer by layer, it actually photo shoots a 2D image by laser, and then that's how you actually made the transition from liquid to solid. So that's why this one is faster versus the SLA, and this one tends to go like roughly $100,000. So from there you go into more specialized equipment. Now this ones tend to range more than $100,000. For example, this one, you might have the material powder right over here, which just rolls right over here, and then due to laser, it just bounces right over here. And then with this powder, that's how you actually start to get from powder to a solid object. So the pros and cons, as you can see, you can definitely apply different materials such as metals or other composites, but you're wasting a lot of material right over here on the powder. You can recycle, but you cannot recycle for multiple times. So you actually end up wasting a lot of material. Then you have other types of printers, but I don't want to go through these ones. Basically, they are the same, a little bit more advanced, but usually these ones are for very specialized applications. So from here, we had different job fields that it opens. So from product design to reproductions to virtual reality and augmented reality, 3D printing, business, visual effects, mobile applications, engineering, chef. It applies to anything. So when it comes to softwares, it is. I was having a conversation about 2 hours ago with a student, and we ended up having a 2 hour long conversation about softwares and then how much it has evolved when it comes to this application of 3D designing and printing. So we ended up with this agreement where there are two different worlds or scenarios, which is this one very simple, which is 3D modeling. So this one is mostly for animators, game developers, CGI artists, which are more focused on entertainment industries. And these are some of the softwares that you can use. Hopefully it doesn't crash, but as you can see, it starts from just a cube, which is, if I were to pause it, as you can see, you have an image and you have a cube right over there. But as you continue every process and step, you might be able to now, from a cube, be able to have an iguana. So you just start to shape that cube, be able to pull it out, extrude it, and modify it, shape it, and then you might be able to have a final iguana right over here. So from there, you start using other software. So that's what I wanted to say, is that you might get to know a specific software, but it's all about, you have pros and cons on each software. So it's all about learning different softwares and how you can use them to your best fit. Or if you feel comfortable with one software, you can do as much as you can with that one. But eventually, if you're doing something very intricate, then most likely you're going to have to change to another software and be able to add on, enhance that model that you're doing. So for example, in this one, it's more like sculpting. That's something that you're going to be able to see later. This is just a showcase. That's why I'm going a little bit faster. But as you can see, it takes time to really model. So that's how it is in the digital world. So from here, what I wanted to show you is just something that is called substance. So as you can see now, it's doing the details, which is the last part. You can see that all of this what started with just one cube. And from there, just keep on adding little by little until you actually were able to have a final iguana, where now this one, you can use it for animation, for video games, or for movies. It all depends to your any applications. Now we're going to go into CAD. So that's what we're going to do today, which is there are introductory CAD softwares. Then you can probably, once you feel comfortable with those beginners CADing softwares, then probably you want to expand more, then you can go into advanced softwares, which are more professionals and they tend to cost sometimes. And then there are other softwares that you can get it for free for 1 year or for a month. And then you actually had to pay for a subscription. Or there are also more specialized softwares. But this is just to give you some idea of how much, or this is just a small set of examples as in terms of how to do some 3D techniques. This is more on the virtual or 3D modeling because the CAD, we're going to do partially some of it later today. So that's why I didn't want to cover it by slides. So this is just for the other side of the world or the other perspective. But as you can see, you start with a box and then you just keep working on it until you actually have the final figure. Then there's also like polygons and triangle modeling. As you can see, you can get to do the same object. This one would take 8 triangles, but this one just 1 polygon. So there are some trade-offs, or as in terms of rendering or as in terms of resolution. For example, right here you have 60 triangles, which is, it's not very accurate, but if you were to look right over here, now you actually get to see 60,000 triangles. So there are some pros and cons as in terms of techniques that you want to do. Again, sculpting, you have been able to see it. There's also simulation modeling. That's more for CAM, which is for engineers, for professionals, for building things, doing statistics analysis, so that way it doesn't break. Because for CAD design, it's more from something that you're bringing from a thought, something that you sketch, something that you have planned, and then you're bringing it into the physical world, into the real world, so that way you can actually put some applications. Versus the virtual 3D design is just animation. You can actually just get to see it. That's the different kinds of procedures in order to do to accomplish it. Then there are very advanced, as you can see, where you actually had to do a little bit of coding or nodes, and then you can actually get to do complex things such as this one. And there's also Boolean, so and not, and then how you can actually be able to do things. So the CAD software that we're gonna cover and we're gonna see today is this one right over here, which is Tinkercad. So this one is mostly more about, if you want to think about it, primitive modeling. So that means that we're starting with shapes, and then we're just gonna keep on editing, and then you can have the final product. There are other softwares that you can use for apps, and on tablets you can also do them. And the cool thing about the CAD softwares that are as beginners or entry level is that they're free, they don't cost too much. Then we have the advanced softwares. These are the professionals that cost. Then we have the specialized softwares that will be a little bit tricky. Then what I wanted to show or talk about as well before we go into the demo is that we have 3D repositories. That means that you don't have to start from the beginning or from scratch. You don't have to reinvent the wheel. You can use some of this already 3D designs and just be able to edit or modify. That's up to you. I would highly recommend. It all depends on your needs or specifications, because you might find something on the internet where yes, it's easy to access, but if you're going to apply something very specific and might not, while you edit it and something like that, you might be able to tweak it a little bit, but at the end, it might not help you at all. So let's take that in consideration. There are websites that cost, there are websites that are free. So I'll put all of these resources, additional resources at the end. Then last but not least, before we go to the demo, is that there is a 3D cloud printing system available for all of you if you're interested. So that means that you can actually get to 3D print from, send some 3D print files from your home. You can send them to our printers. That way we can definitely help you. We can 3D print them for you and for your class if you're thinking about it. So that way you and your students, if you're teaching right now or if you're helping in any specific school, you can definitely be able to teach them or be able to 3D print for your kids or students. So this is just an example of how you can actually be able to see how it's being printed. With that being said, I promised that I was going to make this short and sweet. So we're going to go into Tinkercad. So what I'm going to do is just open a small browser. Then this is what you're going to have to do later on. So basically, you would just go into Google. Then what we're going to have to do is just type into tinkercad.com. So you can just Google it right over here, or you can just type in the URL website. I'm gonna put it right over here on the message, so that way you can just click on it later today once I'm done with this demo. And then remember that there's going to be professional students right over here on each table, and they're going to be able to help you out in case you have any questions or need help with something. But basically, it's right here, this website. You don't have to install the software or anything at all. That's why it's pretty easy to start. And then you can easily just click here, join now. So the cool thing why I wanted to touch this software is because it is also targeted for educators. So let's say that you have a class of 30 students or more. You can actually have your own class and then give them an access code. And once you have that access code, you can get to see how every student gets to start 3D designing. So let me just log in. I should be able to have one right over here. So you can just connect it to your regular email, or you can use your Gmail if you want. Then once you have right here, you're going to go into classes, which is on this part. So once you click on classes, this is where you can create your classrooms. And then let's say that, for example, right over here, you have a class, and then you can just easily send this code to your students, and that's how they're able to join your class. And then you can actually get to see each of their designs right over here. Then this is from Autodesk. So the cool thing is that you can 3D design, but you can also learn other things such as circuits. So if you're interested in learning how to use Arduino, how to program Arduinos, and then a little bit of electronics as well, you can definitely do that. Or if you're interested in a little bit of coding, you can definitely do so right here in Code Blocks. So with that being said, basically what you're going to have to do is you're going to click on 3D designs, and then you're going to click here, create new design. Then once you click on it, then basically it's going to launch a new file right over here. So they always have weird names, so you can always just double click on this one, and then you can just say your first prototype or first design if you want. You want to just name it like that. So once you have your first design, then you can actually go through here, and they can definitely explain it to you. But basically, like I mentioned, this is a pretty primitive modeling. So it means you have a basic shape, which is a box. So you just click on it, and then you just drag it right over here. So this is going to be your work plane. Then, as you notice, I was able to zoom in. It's always highly recommend. It is highly encouraged you to use a mouse. So that way you can actually be able to use the left click to select. Right click, what you can actually do with right click is to orbit. That means go around. It is very critical to always do orbit because you are 3D designing in a 3D world. So you might think that this object is actually on the floor plane. If I'm looking on this perspective or this view, you might assume that it's actually on the floor. But if I were to do the orbit, then I did notice that it's actually floating. So that's why right click using a mouse is very critical. So let's say that right now you don't have a mouse. What you basically are going to have to do is just click a control on your keyboard. Once you leave press the control key, and then do a left click, and then you can also orbit if you do not have a mouse, or let's say that you're on your trackpad. So you can also change right here, click on front on this cube on this top left corner, and then you can also change your orbit, or you can just click on the top view or front view, whichever you want. If at some point you are lost, what you can do is on this left side, you can see a home view. It'll take you right over there in case you were to get lost. You can also do a zoom in or a zoom out. And then something that it's very interesting, or something that I would highly recommend, is you can change into orthographic or perspective. So what it actually means, orthographic, is that if I were to zoom in, you're looking at almost, it looks like if you're looking at an object, a 3D object in 2D. So for example, if you're looking at my hand, it is a 3D hand. Like everything is, it has the X, Y, and Z. But if you were to look at it on this perspective or this view, it looks like 2D. So that's very critical when it comes to 3D designing, is that a way that you can think of is that everything that you see in 3D almost can look like 2D. So that's how you can start also to 3D design. So with that being said, the last things that I want to talk about or let you know about this free software and easy to use is that once you click on this object, if you notice, you're going to have a small set of, I want to say, options. So for example, you had this slider, and if I were to move this radius, it has been transformed from a cube into a sphere. So that's one of the few softwares. There are other softwares that are currently doing this as well, but it would take Node. It's not as simple as doing just a slide right over here. So that's the cool and easy thing about this software. And then just by reducing the steps, you can see that it's going to more polygon shape. So those are the cool things that you can do with this software. Then you can play with the other ones with this, which is just length and width and height. So let's say that you can move it right over here. But what you can also get to do is, you see this 4 corners right over here. If I were to click on one of these corners, then you can just drag it and make it larger, or you can also make it shorter. Then you also see right over here, there's another white square right over here, you can also click on it. That's going to adjust the height. If you are designing something very specific, like you want to do the measurements instead of just eyeball it, you can just click right here where it says ruler. And then just by clicking and dragging this ruler, just be careful where the circle is, because that's going to be your origin point. So everything that you have, if you were to click on this object, now everything is based on that circle. So just be careful about that. So if you notice, now you have all the dimensions, and then you can just easily edit everything right over here. If you're gonna design something very with units and be very specific. Another thing to take in consideration is that right here you have the units. So make sure that you're using the right set. For the most part, it's always standardized to 3D design on millimeters, but you can also change it to imperial units if you want to work on inches. Then the last thing that I want to cover is that there are other objects that you can also change. So that means that it doesn't only work with just radius and just by the steps. So there are different objects that have different features. So just be mindful about that. The last thing that I want to cover is you have this cylinder. So if you didn't notice, it has a different color. And that's because if you notice right here, it is set as a whole. So if I were to click on solid, now it does change the color. And then you can also change different colors right over here. This is just for aesthetics. So that way, probably you're working on something, you have so many objects, you don't want to lose whatever you're working. You can definitely change the colors. But the cool feature about this software is that you have this option that is set as a whole. So let's say that I were to put this hole right over here on the center for the most part. So once I have this, it looks that nothing's happening. But if I were to select both objects, just click and then drag. While you click on it, press on it, and then select both objects, you see that red square. That means it's going to grab everything that is inside that red pointed square. Once you have selected both items, if I were to click on this one where it says group, now you have noticed that I have been able to remove all that extra part, and that's because of this object that I set as a whole is going to remove that solid part, the one that it's been highlighted with the black shadow. So that's how you can actually create really complex shapes. So for example, if I were to go right over here to some examples. So let me just click to the website. I click right over there. Not these ones are very complex, but it takes time. Like for example, if you're interested into X-Wings, you can definitely do so. Or if you want to look what other people has done, you can see that it does look very childish. And the reason is because this is targeted mainly for children that there are 7 and above. You can actually learn how to 3D design. So it looks very simple, but you can actually be able to do as an introductory software. You can do complex things. The only thing it takes is just time, how much effort you want to put into it, but then you can definitely achieve so many things. So that's part of the introduction. I know I did went a little bit quick, and the reason being is because I want everyone to have the chance to work right now for 30 minutes at least. I know I did promise 30 minutes, but I didn't. So sorry about that. But the remaining 30 minutes for you to try it. And then we have students or we have people that can definitely help you out. If you have any questions, I'll be around the tables to help you out. And then the activity, or you have 2 options. One is if you were able to do the previous assignment, which was to create a low fidelity tensor greeting. The challenge is for you to actually be able to 3D design it. So the way we can actually 3D print it. But if you didn't have enough time to work on this low fidelity structure, then you're more than welcome to start designing something that really has your interest. So that way you can work on it. This is some of the examples, and then I'll show you later some of the 3D designs that the students were able to do for this class. With that being said, I'm going to turn off the presentation mode, and then I already posted on the chat the website, so that way you can create your account. And then if you have any questions or anything else, just let us know. We're more than happy to help you out.